This conference will now be recorded.
Hello, everyone, and welcome to the Satellite Book Club seminar. I'm Brian Gockel here, Office of Observations, and title of our seminar today is The Megastorm of December 15th and 16th, 2021. Our presenter today is Andy Just, Techniques Development Meteorologist from Central Region Headquarters. And our facilitator today is David Donahue from NESDIS Office of OSPO Satellite Products Branch. Just a few reminders before we get underway. This session is being recorded. We'll take Q&A after the presentation. Please post your questions to the chat room as we like to field our questions from there. Encouraging you, as always, to sign in with your full names and specify full names when asking a question in chat, especially if you're logged in on a group account. And we always are looking for and welcoming presenters for future Satellite Book Club seminars. So please contact the TOWR-S team. Kashad Bowman and Emily Maddox are on this call, and they'd be glad to help out with that. Furthermore, the training team can help create training materials that might be unavailable or help you locate some that are available. Please contact Ross Van Til for information or questions regarding that. Thanks as always to the TOWR-S team, including Kashad, Emily Lee, and the rest of the team, Office of the Chief Learning Officer, GOES-R and JPSS programs, and our facilitator today, David Donahue. Before Andy begins, just a few words about his background. We're happy to have him here presenting. Andy works as a Techniques Development Meteorologist, Central Region Headquarters, Science and Technology Division. In that role, he supports not only the Central Region, but offices nationally and items such as ForecastBuilder, new product implementations in AWIPS, including satellite product implementations in AWIPS with the TOWR-S team, and sharing ensemble and probabilistic tools. He recently did a tour of duty in Fairbanks, Alaska, acting as their SOO for a while, and visited the Pacific region to work with them on new data implementation in AWIPS. Andy, welcome to the Satellite Book Club. The floor is yours.
All right, thank you, Brian. And I can try to turn my webcam on and see if this works. Yeah, there we go. So yes, again, thank you, Brian. Thank you, everyone. So yeah, this storm system back again, December 15th, 16th, call it Megastorm because it really is a really large synoptic system encompassing a lot of the region. And I just do really love this one image capture of the satellite, geocolor there with the GLM data. Again, it's around 22Z, and it's just very vivid, with the developing linear MCS derecho off to the eastern portions of Nebraska and Kansas, and then you have the blowing dust streams and some embedded smoke in there. The classic comma head region of a strong low pressure system noted there, and indications of just by the satellite image, you can kind of see the idea of a sting jet, which is that tip, the very tip of the comma head there going across northwest, north central Kansas into south central Nebraska. So that's why I call it the Megastorm. It's brought a lot of different impacts across Central Region in particular. As it was coming out of the mountain areas, they were getting some mountain snow and squalls, and then a wide swath of high winds, which were helping to fuel a lot of different of the other hazards here between the, kind of widespread fire activity, as well as severe convection, including tornadoes farther downstream. So I'm going to look at this from a couple different aspects. One from the medium range. One of the things that I'm involved with is ensemble fluency training for the probabilistic IDSS team, and I think this is a really good point to really utilize that probabilistic viewpoint and look at potential solutions for this system. So if we go back to like December 10th, so we're looking about 5 days or so out. This was really amazing in terms of the amount of agreement that we had in the ensembles. If you've looked at clusters before, this is essentially being able to look at the Canadian, European, and the GEFS ensemble suites. And if you put them all into common, 4 common sets in terms of where things would be at 500 millibars. Again, you see this very strong ridge downstream of a very deep trough over the west coast. Interesting to note, so again, as we're detailing, this is a very high impact system across much of the central region. December 10th is also the day that there would be a long track tornado that tracked across portions of northeast Arkansas and western Kentucky, and I have a link to the to Paducah's storm summary from that event. So it's like you got two fairly high impact events almost back to back. One of my favorite products I like to look at is the European Ensemble's Extreme Forecast Index and Shift of Tails. And this is just an example for high temperature. And given the fact that there was a really strong anomalous ridge, it's really not surprising to see very high values for maximum temperature. What I think is surprising though is the fact that this is a 5-day forecast and you're already seeing these high EFI values. And the black contours representing the shift of tails reference, they're the top 10% of the European Ensemble members, and essentially this is suggesting, given that overlap of high EFI and high SOT, is the that you're maybe not even dealing with just daily records, but perhaps monthly ones as well. Noteworthy though is that even with the agreement that we have at 5 days out with the ensemble data, that there's still some differences, and one of my favorite products to look at for that is the max temperature standard deviation. And you'll see it's really high across northern Nebraska into southern Minnesota, and this is just reflective of differences in the storm tack, and also some degree, this is mid-December when you have snowpack on the ground in some of the northern locations. So I think that's also getting into these max temperature forecasts. So this is where oftentimes you can utilize your messaging to convey the uncertainty with these different factors, storm track timing, and the influence of snow depth into the model guidance. So if one thing I do like to look at too is a simple chiclet display of where all the high temperature values land. And most of the ensemble suites provide, and even deterministic models for that matter, provide high temperature data in 6-hour time steps. And so in this period, I grabbed the 18 to 0Z time period for Sioux Falls, and you saw that previous slide with the max T standard deviation at 10 or 11. Here we are again with this huge spread in the ensemble data from a 32 temperature all the way up to a little over around 70 degrees. And I did, for the fun of it, plot it up as a PDF just to see is it bimodal, is it anything like that? But no, it's a nice classic type normal-ish distribution there with this data. Again, this is the strong agreement with this really anomalous ridge, deep trough. You can kind of envision that this would be a very potential for very wrapped up system, and therefore end up with a lot of wind. And so if you look at extreme forecast index for wind, we see that clearly here, very high values. Again, we're looking 5 days out. So right, and with the black shift of tails of a 1 already, suggesting again from a messaging perspective, we can jump on this and say, hey, there's going to be a widespread high wind event, very anomalous temperatures. And if you want to combine the two together, you start to be worrying about severe concerns as well. And so that is shown here. So the European itself, the Extreme Forecast Index, does have a Cape Shear analysis, and so we're gonna merge the two components and look at, so a little quick background. So the Extreme Forecast Index looks over a 20-year time frame of that of its data set, of its reforecast, if you will, and creates what basically is a model climatology. And for these Cape Shear parameters, you can see already that we're at 5 days out getting several areas, particularly from the Central Plains to the Upper Mississippi Valley, of higher EFI. It's not crazy high, but it's still really suggesting, no, we better watch out, including the black shift of tails, suggesting that there's some members with much higher values of a combined Cape Shear. In the MBM, there's a CWASP, essentially it's like a, I think it's a Craven-Wiedefield accumulated severe parameter, I think is what it's named. And essentially they combine like 30 different severe weather items into it, like supercell composite and all that. And what we have plotted there is already signs for some severe weather. That's at 21Z. Actually, I should say December 15th, not December 11th. But those values are creeping up there. Now, they're a little bit downstream of the European Extreme Forecast Index, and that might be just because of the, you're blending all the different guidance together, and that's where things heat up. But you definitely want to watch, especially the northwest end of something where, some of this gradient is happening in the CWASP product. So now we're going to move here into the short-term time frame. One important note is, this is December. Obviously, all the grasses have dried out, and including on top of that, there was a general drought in place. So looking back at December 14th, so NASA's Land Information System data really hints at, hey, there's very little soil moisture at the 4-inch level. So, everything's, the fuel's essentially kind of ready there to burn if you had some sort of ignition source. And of course, the weather itself. I mentioned before about the max T standard deviation having a high spread to it, and snow depth being a potential factor. Here's the snow depth for 12Z December 14th from NORISC. And then it's interesting because you kind of have a general colder spell from December 10th through the 13th, and even a little bit into the 14th. And then we're going to amplify that ridge and shoot warm air northward. Watch the snow depth disintegrate quite a bit there by 12Z December 15th, and I'll kind of rock back and forth between the two images. I recall going into this event, this was one of the big question marks, even back on December 10th, was the northern extent of that severe weather. You recall the previous image from the Extreme Forecast Index bringing high values of Cape Shear all the way into southern Minnesota, and that, well, there's snowpack on the ground. Is the snow going to be, going to be there, or is it going to prohibit the severe weather? But we're actually going to see that basically most of the snowpack evaporates during the day on the December 15th. And a lot of that's due to just really intense moisture transport. Certainly these integrated vapor transports, they're looking over a deep layer. This is coming out of the NAIFs, and this is more like in a short term, but you really see things intensify as that trough that we had seen earlier lifts out into the northern plains. Those red values that are depicting that we're basically outside the 40-year climatology around this point, basically encompassing much of December. Precipitable water too with this event is pretty impressive. As you would expect with such a strong system pulling moisture northward. And you have a fairly open Gulf in this situation. You push precipitable waters up 1.1 inches or so at Green Bay and Davenport, which when you go into the SBC climatology page, those essentially are record values for those sites. So again, really, really impressive. Back earlier when we looked at this from the extended point of view, there were high values for the EFI and ships of tails, but there was still some spread because EFI was only maxing out in that 0.8 to 0.9. Well, now in this 24-hour forecast, looking back at this from December 14th, we see that things have really ramped up. Basically, all the models, at least the European ensemble members, have come together on a really high, really strong winds relative to the model climatology. And that top 10% is really strong. So one of the cool things is on the European ensemble chart, or European chart website, you can get CDF diagrams for the EFI, and so you see the winds plotted. And this is for Omaha in the bottom left. And what we see on there is the blue lines are like older forecasts, the purple and red are later forecasts, and the black line is what the model climatology should be. And so the very bottom of that is like near 0%. So essentially at 20 knots or 20 meters per second or 40 knots is where the, why would that be, the least windy ensemble member is for the max wind gust. And then that top 10% of the distribution is sitting at like near 60 knots and higher. So it's just very, it's very impressive to see this. And again, you got such a wide spread between the model climate, which is in black, and the ensemble or the forecast. So you end up with that really high EFI stretch, that that pinkish color that extends across Kansas and into Nebraska. So NBM version 4.1, how it handled this for a wind gust forecast perspective, really high gusts coming across southern Colorado as the trough moves out into the plains. Noteworthy, some 80 knot gusts in southeast Colorado. It turns out to actually be pretty close to the observed. Now, I will say that the NBM 4.1 did have some bias towards higher wind gusts, but I think in this event, some of these wind gusts were actually really close to what ended up occurring. And then again, those spread in east and northeast with time as the system lifted to the northeast. So I did want to talk a little again back on some fire weather items. The NBM, min-RHs, all that downsloping of the winds coming off the Rockies really dry things out. But again, you've got that high EFI from max T, so you got that warm surge above, drying from below. So you get these really low min-RHs, and really you see the dry punch nicely in the dew point image from the HRR at 21Z with single digits. The HRR sometimes can overmix, but needless to say that, yeah, you have a really strong dry wedge, and it lifts all the way up into eastern Nebraska. So some of this fire weather concern ends up lifting way farther northeast than usual for what you would be looking at in December. Interestingly, now we look at this from a severe risk perspective. Those lower EFI values we saw 4 days prior, yeah, those have greatly increased. And basically all the European ensemble members suggest now really strong relative to model climatology for Cape. And I mean, it's December. You don't get a lot of caping usually, but it's really well evident that, hey, we're going to have something significant going to happen with given those really high EFI and shifted tail values for Cape Shear. CWAS thing hasn't changed a whole lot. Still at threat there. And then if you actually look at the HREF in terms of its forecast development for convection, it's you see the ensemble paintballs there. Again, this is a 36 or 42. I think it's like 36 hours out. Really see a nice QLCS type development forecast in it. And of course that you think back to that satellite image I shown at the very beginning. Boy, that looks really similar to the the GLM data there with that HREF max reflectivity paintball plot. If you are curious, I did have a sounding from the HRR at 21Z on the 15th. This is before the forecast squall line comes in, and I mean that photograph is just intense. Ooh, thanks Bill. I'll respond to that here towards the end, but that would be a cool link to look at. But yeah, there's not a lot of cape in that sounding, but hey, you've got strong force in plus that cape. That's a bad situation right there, and rightfully so. And you'll see find the impacts, what ends up happening. So here's one loop. Here's a couple of satellite loops I have over the next or images over the next couple of slides. Just the system is impressive. This is just simple, some true color imagery out of the. You can see the blowing dust as it starts getting going once the dry line and Pacific cold front pass were related to this system. And you can see the convection blowing up. You get the horizontal convective rolls too farther downstream to the east in this imagery. You also have you can see like the moisture transport region with the higher clouds off to the east of the convection as well. Just a lot of good things, and again, you also see the sting jet there that develops here in eastern Colorado and then lifts northwest Kansas up into Nebraska. Just really, really cool imagery. Another look at this same region from so Todd Lindley and others created this paper. I have the link there to it on preliminary use of convection allowed models for fire weather. And they're using the Texas Tech WRF where it creates this red flag threat index, and that red flag threat index is a good utility looking at, especially the grasslands of the central southern plains. And when you see these values in this loop, they're going to creep up to this 7 to 8 region and even 9 to 10 over central Kansas. And it's really cool in this loop to see the overlay of the RFTI with the I think it's 3.9 micron with the various hotspots that show up across from Amarillo's area all the way up into Kansas. And you definitely see this really deep, really wide hotspot that develops over north central Kansas, and we're going to touch on that here in a second. Another look at this from the satellite data, and we have overlaid with Wichita again, or satellite data overlaid with radar, courtesy of the Wichita office. The radar imagery picking up on a lot of these different fires, and you're even seeing it too on satellite imagery. The blowing dust shows up very nicely in this image as well. Ooh, I like the bugs. And then the wildfires. So this was just a really bad wildfire that started up. And actually this event even, I know Goodwin commented one of the problems is that the winds were so strong, there was sparking sometimes going off of the wire fences and whatnot, and those started fires, and those fires are in the same regions as the blowing dust is occurring. So very hard to tackle all this fire activity, especially given the fact then when fires do go, you've got winds blowing 60, 70 miles an hour, sending them downstream. This wildfire that represented here, grew from basically nothing to several 100,000 acres in just a couple hours. Did grab a courtesy of the Omaha office. They have a radar loop here, and you just see this with all you couldn't get any really sustained supercell structures by themselves because there's such strong dynamic force. And having said that, you end up with this really strong QLCS line, embedded bows, embedded supercell structures, which is why we end up with a plentiful severe weather in this case. And this was the map of the day one outlook overlay with all the storm reports courtesy SBC, and again, you see there's tons of strong wind gusts. Not surprising. Again, the EFI and everything for just the non-convective wind side of things was very strong. You saw the sounding from Council Bluffs earlier with a lot of wind in it. So again, very, very impressive. Couple of fun facts. La Crosse office mentioned, they had their strongest tornadoes that were rated EF2 were in north central Wisconsin, where the snow depths were 4 to 6 inches the day prior. And that snowpack mentioned earlier just basically evaporated with the strong warm advection and moisture advection. EAX here having smoke and blowing dust observed from the fires out in western Kansas, including in my house. I remember going outside during the evening after the front passed, and I'm like, what's hitting me in the face? And I realized it's all blowing dust. In Pueblo's area, I think this ends up being one of the highest wind gusts in this entire event. Lamar, Colorado, that was where the sting jet was starting to develop. Was 107 miles per hour. And then again, that aforementioned Fort County wildfire in northern part of Wichita's area ends up being over 350,000 acres. So again, there's a lot to this event, and given its wide area and scope, and here at Central Region headquarters STI, we actually worked with the various offices to see if they could come up with that were impacted by this event, to come up with some, what happened in the event for their areas and some good lessons learned. And I have links to those here. They were presented during two webinars on our CR guest speaker series back in February of 2022. And feel free to watch these links. And otherwise, if you have any questions, just feel free to reach out to me. Again, my email is there.
Thank you, Andy. Stay tuned for the discussion. We encourage participation from the field forecast offices and regional headquarters, as well as for attendees to specify their full names in the chat when asking a question. Okay, also keep an eye out for the Google chat, as our team will use that for communication. Now, at the conclusion of the presentation, okay.
Yeah. So I can talk to first Bill's question about the chance to look at the snowmelt RGB. I had not at the time, but that would have been, I think that actually would have been really cool to check out. And I like that you have the next question item there. Scott Lindstrom mentioned about true color imagery loop from this event available. It has the archive link, so if you can see that in chat, I would recommend to go check that out. Brian Curran knowing about the gravity waves emanating from this. Yeah, this was just an incredible event to see that happen. I agree. Yeah, Patrick up there in Duluth mentioning about the muddy water from the dust that was drawn in. Yeah, this was yeah, there's just really strong advection of all this. I know blowing dust, some of the dust, and even the smoke smell even came all the way up into like even Cross's area and that. And Patrick also provided in chat the link there to the talking about the EFI shift of tail reference from the Central Region Southeast Sioux group. So lots of good stuff there in chat.
Okay. In a week from today, on Thursday, September 28th at 12 p.m. Eastern Time, Dr. Juan Meng, physical scientist from NESDA STAR, will provide an update on the radar satellite blended snowfall rain rate. You can contact the TOWR-S team, Kashad Bauman and Emily Maddox, for questions about the satellite book or for configuration of satellite products. So if there's any more questions, please put them in the chat. And we can keep moving here.
Ooh, I like Bob. I like seeing your chat there mentioning that the let's see here, the Cloud West group has developed a simulation case for this event for the Goodland and Pueblo CWAs. That's really cool. You know, I mentioned about the mountain snow. I didn't even try and cover that all entirely, but you know, the soundings were extremely impressive coming out across the plains. I do remember that there was some, even though they were short squalls, there's some good impact, or you know, some problematic impacts there in the Pueblo area from this event.
Okay, well, if there are no more questions, I'll turn it back over to Brian for final remarks.
All right, Andy, thanks very much for that informative brief. And Dave, thanks for your facilitation. We're a little ahead of schedule, or a little early today, so there's still an opportunity. Just recheck in the chat. And I'm not sure we got, is this another question from Doug from Cleveland? We got a couple more questions coming in. Did the CWAS product provide any utility for separating this extreme event from, say, an ordinary severe event? Andy, would you be able to comment on that?
Yeah, I don't, you know, given the fact that there's no kind of the model climatology, if you will, to it, you know, if you were to overlay that, if you did have like a reforecast-ish climatology for the sea wasp over, you know, the time frame, like kind of like the EFI shift of tails has, that would be really cool. You know, that would be really cool. And because I bet some of those sea wasp numbers are, you know, way off the charts of where they should be up in anywhere, especially up north of I-70 for this time of year.
Yeah. All right. And a question, comment from Bill Schoberg. Was there a lot of local and national news on this event? I think I know the answer to this question,
Yeah.
but Andy?
Yeah, definitely, especially if being classified, you know, I think the convective aspect, the being classified derecho was one. Tons of local coverage too from all the areas. You know, the fire activity in Kansas was covered a ton. Yeah, you can go up and down the the list of different things you know, being covered on this event.
Yeah. Yeah, we had no weather going on the East Coast, so we were watching it from here.
Yeah.
All right, and last call for any other comments or questions for Andy. Great presentation. If you missed part of it, it'll be recorded and posted. And not seeing any. Thanks again, Andy and Dave. Great presentation. And as Dave mentioned, we'll welcome you back a week from today. Dr. Juan Meng, physical scientist from STAR, providing an update on the radar satellite blended snowfall rate product. Look forward to seeing you then. Thanks for joining us this week's Satellite Book Club, and we'll see you next week.